about WebGPU and Deno. So please invite me in welcoming on stage. He's already here. Leo.
Thank you. So today I'll be talking about the history of WebGPU in Deno. It's more complicated than one might think. So I'm Leo. I do web developer stuff. I'm software engineer, web APIs, and documentation related stuff at Deno. So what are WebGPU and WGPU? I'll get into details right now. WebGPU is a successor to WebGL API and provides a lower level API compared to it. It's more nitty-gritty, more similar to Vulkan, if you're familiar with that. WebGPU was originally proposed by Apple in 2017. However, the API, as it is now, does not really have anything to do with that much anymore with the original proposal. But after Apple proposed the WebGPU API, Mozilla proposed Obsidian, an interesting name, and Google proposed NXT. I'm not sure who's coming up with these names, but the WebGPU name was the winner. But the community group further discussed APIs, and in the end, it was a bit of a merger of the three different proposals into what now is the API that is known. And during this talk, I'll also be mentioning WGPU a lot. WGPU is Mozilla's implementation of the WebGPU specification. A big part of WGPU's history is Dmitry Malush, Quark, had an idea of unifying all GPU APIs under a single abstraction and iterated towards it, starting with the GFX Rust crate, which was designed to work on top of DX11 and OpenGL. Then a follow-up iteration was built on more modern APIs, DX12, Metal, and Vulkan, which implemented a Vulkan-style API on top. So you could use the different systems only using a single unified API that was similar to Vulkan. And then there was a final third iteration, which is WGPU, which is the crate that's used today. Yeah. Now some Deno internal structure. Since I'll be speaking about WebGPU and Deno, you might need to know some of how the internals of Deno work. The common understanding of technical details. Deno is split into multiple building blocks, but everything starts at Rust V8, which is just an abstraction. It's Rust bindings to V8 directly. On top of that layer, we have Deno core, which is a bunch of utility functions and other structs around V8 that make things more Rust-like and simpler to use, such as creating a JS runtime, generating snapshots, and having Rust functions that can be called into JavaScript, which we call ops, which will be relevant later. And a bunch of other capabilities are added on top as well. Then we have the extensions layer, which is different building blocks that implement various different APIs, for example, the Fetch API, Crypto, and WebGPU. Extensions contain both native code and JavaScript code, which the JavaScript code is what we use to define the web APIs interfaces. And for the WebGPU extension, the JavaScript part is quite extensive since the API surface is quite large, about 205 kilobytes, which will be quite important later on. After that comes the runtime. The runtime is just glue code that puts all these different components together and adds some additional web APIs like Worker and some other functionality. Here's also where APIs are assigned to globals, etc. Finally, we have the CLI layer. It's just where various subcommands, etc., JS APIs related to those subcommands like testing and benchmarking are implemented and live. And that's the simplified version of the Deno's structure of internals. So how did implementing WebGPU start out? I started implementing it, the specification in October 2020, more or less. And the initial main effort was basically 2 weeks of mainly sleepless nights. And no, these are not the working conditions of Deno. That's just my insanity. While I was not working on Deno yet, was just doing this as an open source contribution. Most of the implementation involves just creating bindings to Rust and WGPU crate. but which is, again, Mozilla's WebGPU implementation. Everything afterwards was a lot slower and just fixing bugs, iterating on very smaller issue, and aligning closer to the specification itself, which was done together with Luca. We came across multiple issues, but thankfully Quark, who at the time still worked at Mozilla, was able to answer a lot of different questions and help us out to finishing up the implementation and a first pass of it in March 2021. But if that was all there is to it, then I wouldn't be giving this talk. Because additionally, we are also a bit more involved with WGPU itself nowadays. There's currently a bit of complexity that since November 2021, the source code of Deno's implementation lives both in the Deno repo, but also in the WGPU repo as a shallow clone, and which is not ideal. This is due to WGPU folks needing to have the source code as well because they want to use it to run the CTS, the conformance test suite for WebGPU. And we cannot have like a shared implementation because WGPU needs a version of their own, so they can use the latest version of the WGPU crate and iterate on it on the extension implementation, while we have our own Deno core crate, etc., that also needs to be always on the latest version, and having a common place would just make iteration for both parties too slow. So we have this shared code base, well, not shared code base, but split code base where there's slight misalignments of the implementation that every month, more or less, I go and line up again, which is not ideal. So having some solution around that would be ideal, but we have not found anything viable yet. And since September 2023, so last year, Deno also is part of all the WGPU and overall administration team and discussions around those. So what's the problem then? Well, we will continuously keep the implementation up to date. The size and the startup time for Deno increased by a lot. Well, and also complexity. But complexity was something that was bound to be the case. WebGPU is quite a big API. It's not something simple. The size and startup time became a major issue, which led us to having to completely remove the API for a lengthy period of more than half a year. We had to remove the implementation in March 2023 after multiple discussions and back and forth with the community, which in the end the community was not really happy about it, but we had to do it. The main two issues were that the main issue was due to size increase and increase of the JS snapshot size, which was a partial reason for the large increase of startup time for up to 5 milliseconds, so from 14 to 19 at the time. And the binary size increase itself was not really too much of a concern, as it isn't that big of an increase by itself. So what do we do about the issue? Well, there were two main causes. The first one was macOS specific. On macOS, WGPU and its dependency includes various frameworks like Metal framework that are dynamically linked on startup, which are increasing the startup time a fair amount. The second more complicated issue is that the snapshot size increased by a lot. Deno uses V8 snapshots under the hood for faster startup time. However, due to the amount of JS code added by WebGPU, again 205 kilobytes, the size increase of the snapshot increased significantly, that it affected startup time dramatically as well. So, macOS static framework. One large issue for macOS was the linking of the frameworks. So WGPU depends on multiple frameworks like Metal and some other graphic-related frameworks, and it pulls them in that are required, and which increases the startup time for all users, even the ones that don't care about using WebGPU. It's still a relatively niche API. And we thought that there was no way to force these frameworks to be weak without a nightly ROS feature. But and in Deno, we don't want to build with nightly Rust. Just it's a decision we made. It avoids us headaches in the future. So we ended up patching dependencies and adding an optional flag in dependencies that is a link feature, which is enabled by default. And if disabled, it would not statically link these frameworks. But later on, we found out that this was completely unnecessary. And we ended up patching up those dependencies again to not need having those patches. So that more or less increased the startup time by 0.5 milliseconds, which is not that much of an improvement, but every bit counts in the end, about 3%. The other issue is snapshot size increase, which is quite problematic, and we were not sure what the best solution around this was, which is why we went the route of completely removing it for half a year. So we had some APIs that weren't part of the snapshot, so we were thinking that maybe we can do it like that. But however, these APIs that were defined on a higher layer of the Deno CLI, so on the CLI layer from earlier, but web APIs are on a much lower level on the extension level, which is problematic to not have there because we define the globals in the runtime level, so we cannot implement that on a higher level necessarily without causing potential issues. So we came up with a solution. Have ES modules that are lazy loadable internally. We have an internal struct called a module map in the Deno core crate that contains various things like the module loader, the pending evaluations, and most importantly to us, data about modules in the current execution. The data mainly contains things like handles to the loaded modules, information about set modules. Here we added a hash map keyed by the name of the lazy loadable module, if we want to call it like that, and that's by the name, and value is the source code of that module. And then this data is stored in the data section of the snapshot. To load these modules, we added an internal JavaScript API that we call create lazy loader that accepts a specific specifier, which needs to be a valid loadable specifier, and returns a function that, when called, loads the module. Once loaded, the value is stored, and calling the lazy loader again does not reload the module every time. It's just one-time thing. And then instead of using a static import, defining the APIs like we do for non-lazy loadable APIs, we create a lazy loader and then call it in the navigation.gpu getter. And then we change the globally defined interfaces to WebGPU to also be getters instead of just purely properties that are defined on the globals, like usually web APIs we are, at least in Deno. And those also then called the lazy loader. The one drawback to do this initialization of lazy loader module isn't as fast, since the change we did is akin to changing from a static import to a dynamic import and just instantly calling await on it. But since the user base for WebGPU is so small, and I would say maybe less than 1%, even way smaller than that, of Deno, the few people can afford the trade-offs for one-time small expense, which I think is relatively viable. And after all these following changes, we reintroduced WebGPU in Deno in December last year without increasing startup time at all. And yeah, so what's next for Deno and WebGPU? Well, weak linking frameworks still loads them up. However, it doesn't initialize them. This is being worked on, and when we land it, it will save about 2 milliseconds up to 8 milliseconds across macOS versions, taking startup time down to 13 milliseconds for Deno. We also need to enable the WebGPU CTS. We have the runner, but it's not being run yet due to various complications. And after recently adding support for APIs like image data and image bitmap, the next step is implementing off-screen cameras in Deno, which I'm currently undertaking and is nearly complete. Following that, we'll be also looking into supporting canvas rendering context 2D through Velo, with whom we have been in discussions since a few months. And since Servo is also considering to use Velo for the same exact use case, there is a shared interest, and potentially there can be some collaborative effort to address any issues with Velo that come up, and with a common abstraction layer if necessary. And that's it. Thank you for listening, and yeah.
Do you have any questions?
Yeah. Have you been following the like lazy modules proposal in T39, and do you know how much your lazy SM is similar to that?
I have not been following that. I'm not really familiar with that aspect, but it's more of just how we define APIs internally. It's not too much related to that, I believe. I'm not entirely sure. But yeah, I wouldn't really be able, I've not looked into that proposal.
All right. Who's next? Any more questions?
I know you said the number of users of this Deno users for WebGPU is quite small, but I can also imagine that they might be quite significant users. So do you have awareness of who is actually using it and depending on it and
Yeah,
what they're doing with it?
It's the active people in the Discord. It's I would say like 10 people use WebGPU in Deno, which is not that many, honestly. But we are aware of them and their use cases. But a one-time payoff of startup time of WebGPU Extra, which is relatively insignificant. And most people that use WebGPU probably will use it for more extensive applications, like maybe window rendering, which we support, or some computing with machine learning. That's always going to be a single one-time cost at the beginning of your application when using the first time calling to the navigator.gpu accessor. So I don't think there is any concern even from them that much.
Right. More questions?
Have you checked the increased size part of the snapshot? Like, are they mostly functions code or objects?
It's mostly function code. I've not looked too deep into the snapshot size itself, but it was relatively. I mean, there was some different increase with just adding the lazy loaded at the end of the data part of the snapshot, but I did not really investigate too much into that since our main focus was trying to get rid of the general use case, and it increased startup time, and that was the main focus to achieve. Again, ending compile time of Deno did slightly increase compile size, but it was so minimal that it didn't really matter to us. It did, though, also increase memory usage to do the lazy loaded module, but it was a worth trade-off, we felt like, and not such a massive. I don't have exact numbers in my mind right now, but it was viable enough.
Any more questions? No. Well, thank you, Leo.